Okay, for today's lesson, we're going to talk about significant digits. In chemistry, significant digits are important because any number you see, you must consider to be measured. And the significant digits in a number allow us to know how accurate a number is. Okay? So we're going to talk about how you can look at a number and identify which of the digits inside the number are considered significant digits. And we're going to do that with 3 easy rules. The first rule is that all non-zero numbers are always significant. Those are the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. All of those numbers, anytime you see them, are always counted as significant digits. So some examples we have are, for instance, the number 6. In the number 6, there's only one number there, and it is a non-zero number, so we would count it as significant. So that number has one significant digit. In the number 124, there are 3 numbers. All are non-zero numbers, so we count all of them, 1, 2, 3, as significant digits. And the number 6,783, all of them are, again, non-zero numbers, so they all count. We have 1, 2, 3, 4. Notice that I'm ignoring the comma here. So 4 significant digits. How about the number 1,556,738? Again, in this example, all the numbers are non-zero numbers, so they are always significant. So we would count them all, and we would just ignore the commas here. So we have 1, 2, 3, 4, 5, 6, 7 in that number. Okay, seems pretty easy, right? Well, let's go on to rule number 2. Rule number 2 says all leading zeros are not significant and can be crossed out or ignored. Okay, so not significant in this case. So let me show you an example. In the number 0.003, we notice that we have zeros that are leading the way. That's what our leading zeros are. They're the ones out in front. Okay? Now again, they are not significant, and we could cross them off or just ignore that they're there. Okay? So these 3 zeros do not count as significant. So in this number 0.003, only the 3 is a significant digit, that one number. It doesn't change the number to 3. It is still 0.003. We just understand that these zeros are not significant. Another example, 0.4. Again, we have a leading zero. So we can ignore that it's there and just count the 4 as significant. So we have one significant digit. So in this number 0.4, only the 4 is counted as a significant digit. Now, let's try this example. 0.0456. In this number, we look out in front for the leading zeros, and we notice that we have 2 of them. Well, they are not significant, so we can ignore them and count all the other numbers. So we have 1, 2, 3 numbers that we can count as significant. Alright, for our final example, we have 0.000560. Now, again, we're looking for the leading zeros. So we start in the front, we find that we have leading zeros, and we can mentally ignore them, or we can cross them out if we'd like, just so we don't count them. We only cross off the leading zeros until we get to a number that is not a 0. Notice that there is a 0 at the end, but because it's not leading, it becomes significant. So we're going to count these. 1, 2, 3. right. Now for our very last rule, rule number 3. Trailing or following zeros are not significant unless there is a decimal. So this rule kind of has two parts. Trailing or following zeros are not significant normally. But if there's a decimal, then they are significant. So let me show you a few examples of that. Our first one is 4,300. And I'll put a comma in there because you may see that occasionally. We ignore the comma and we look for any zeros. Notice that these zeros are at the end, so they are trailing zeros. There is no decimal, so we just read the first part of this. Trailing or following zeros are not significant, so like the last examples, we could cross those off if we wanted to. In this number, only the 4 and the 3 are significant, so it has 2 significant digits. Now, this number is still 4,300, but there are only 2 significant digits inside the number 4,300. Alright, our next example is 5,006,000. 500,600. Now, again, we're looking for any zeros and decimals. There is no decimal, so we see that we have trailing zeros. Trailing zeros are not significant, so these zeros at the end we could cross off to not count them. You see these zeros in here? These have a special name. We call these sandwich zeros. Sandwich zeros are significant because they come between 2 non-zero numbers, kind of like a sandwich. The 5 and the 6 would be your pieces of bread, and the zeros in the center would be your lettuce, tomato, and your meat, everything you need to make your sandwich. So the 2 pieces of bread, the meat, that's your sandwich right there. All of that counts. So in this example, there is a 5, a 0, 0, and a 6, so that's 1, 2, 3, 4 significant digits. 2 more examples. We have 89.000. Now this is where the decimal rule comes. So it says trailing zeros are not significant unless there is a decimal. Well, in this one we do have a decimal, so it's the opposite. They become significant. All these zeros at the end are significant. They are important for this number. So because we can't cross them out, we count everything. 1, 2, 3, 4, 5 digits are significant in that number. Okay? And for another one, we have 780.0. In this example, because we have a decimal and zeros at the end, they are significant, so we count them all. 1, 2, 3, 4 are significant. And if you wanted to, you could keep adding zeros to the end to add to the number of significant digits. So that number, 780.000, we added 2 zeros to the end, so it does change the number of significant digits. Now it becomes 6. Alright. Hopefully you learned all the rules well, and now you can complete your notes and complete the practice problems at the end.